UDC.
So when we start thinking of utility network, we think of a lot of challenges. And some of those challenges were completely new data model, new technology, everything was service-based architecture. With ArcGIS Pro, there were performance anxieties, there are still, right? And our existing integrations. So we see the opportunities in these challenges. The opportunity was reevaluate, review our data model completely and get rid of the old and unwanted or legacy data that is not needed anymore. Same with our workflows. We reviewed our workflows and tried to optimize them to suit the utility network data and the new technology. Integrations, we reevaluated all our integrations and tried to adopt the service-based architecture. To get these opportunities, to make these opportunities happen, we need some careful planning. So part of planning was doing a POC or a pilot project with UDC for a small area of our service territory. So how that pilot help us? That pilot help us to see the data migration process, how it works, what are the issues in our current geometric network data. So we were able to fix our data at source, we are still fixing it, and reevaluate our integrations and see where they fit in the new data model and the new service-based architecture. Another part of planning was to check the in-flight projects. We try to schedule our utility network migration project so that it will not conflict with any other major projects in our organization, so that our baselines and timelines will not be impacted. And we try to stick with the network management release plan of ESRI. So these were few planning steps we did to take the benefit of the opportunities. Then comes the system architecture. So we considered following factors for our system architecture: usability, scalability, reliability, performance, data integrity, security, and integrations. So performance, I will go with performance first. Performance is a key point for our implementation. If our system performance is not good, users will not adopt it and users will not be happy with the system. So what we are doing to keep the system, like to make a good performance system, is we are trying to size our environment. We project the usage of the system, like what is the current usage of the system, how many editors, how many viewers, and how that usage will grow for next 5 years. And based on that usage data, we have the architecture workshop with ESRI and size our system appropriately. And another thing that we are doing here is we are keeping our non-prod system specifications similar to the production system. So that will capture and mitigate any performance issue in development phase rather than later in the go live. So that's another thing that we are doing for performance. Another things are database tuning. We are involving our DBA from start of the project, and we are capturing any database tuning issues in beginning of the development phase. Another part is map configuration. We are configuring maps, the number of layers, visibility scales, symbology. Some symbols draws faster than another. So we are keeping in track all these factors. Then ArcGIS server configurations, like the heap size of the services. We are tuning the heap size to provide the optimum performance. So these are the steps we are doing to make our system perform well and to capture any performance issue in the development phase, but rather than waiting for production implementation. Then other things, usability. So we are tracking all user requirements and well-defined user requirements and test cases to verify that each of the user requirement is met. So that will increase the usability of our system. Stability, we are doing intensive tests to give a less crashing system that will not crash and provide good performance to the users. Reliability, we are adopting standard practices like having the high availability ArcGIS portal, regular backups in case we need to roll back. And on the reliability side, we are also using the monitoring tools. We implemented ArcGIS Monitor and another monitoring capabilities to monitor and capture the issues before they can impact the system. Data integrity, we are using the attribute rules, validation rules, contingent values to make sure the good data goes into system. We have the regular data reviews. Security is maintained by the very granular user roles to give access to data and services, multi-factor authentication, and no access to database. So with utility network, nobody needs direct access to database. Everybody is interacting with system using feature services and integrations. For integrations, as I said earlier, we are trying to move all our integrations onto service-based architecture. And there are a couple of integrations with legacy systems, which we are not planning to move forward with. So we are trying to fed those legacy system with existing geometric network data, and we are building a sync tool for that. And Dex will tell more about the sync tool.
Thank you, Sunil. Change detection, the sync solution, right? I know everybody wants to know what this is, because it's like, see it in your face, everybody's really excited. As Sunil said, DIVA had a lot of projects going on. They were trying not to make sure that projects weren't overlapping the UN transformation. There's a project, the NMS and OMS, that there's a slight gap. So this solution was really to fill that gap. As the UN migration goes live, later on is when the NMS and OMS is going to go live. So, but they needed to keep the operational pieces still going. So what this tool does, it tracks the changes in the GN. And then what we do is we use our mapping, schema mapper is what we call it. What that does is it maps the GN to the UN. And then our Heidi tool, which will do some automated fixes. Again, we prefer you do the fixes in the source first, but as we know, sometimes that all can't happen. And then it gets pushed into the UN. What this does is allows for uninterrupted operations for the OMS that they're currently using, and it ties over that gap. So the other reason why the solution is only a solution, this isn't a product, is because this is a very temporary for DIVA. That was the main focus for this. Joe will go a little more detail about when they're going to go live with the UN and the migration. And again, like I said, that process, so this is a one-way sync. So why is this a one-way sync? What happens is, as a team, we evaluated the bidirectional sync, and because of the complexities of the UN, going back to the GN, didn't bring the most business value. So we felt that going from a GN to UN would be the biggest bang for your buck, essentially. So now I'm going to hand it over to Joe to discuss the UN approach and timeline.
Migration, configuration, deployment. Not. There's actually a lot to it. There's a lot that has to go through. You really have to think about, as Sunil said, we have all these other objectives within Dominion. We have parallel projects. We've got other deliveries happening in 26 that we have to worry about. We have OMS coming up. We really have to define the core areas that we want to try to manage over 3 years. So we have to take one step at a time. So what are the core areas we looked at? Work system architecture, as Sunil outlined. We looked at the data, which is the data from the geometric network over to UN. We looked at all the applications that would be affected. We looked at all the integration points and change management, OCM, which is the people. We can't overlook the stress that it puts on the staff because you're adding this extra work. So we have to be very accommodating to them. We also have to ask ourselves, are we a beginner? Are we intermediate? Are we advanced? Dominion's a very mature GIS user. The editing tools have been there for 20 years, as an example. So there's a lot of work that has to go through to get there. So it's a lot of planning, a lot of communication, and a lot of monitoring. Came up working with UDC because we started with a POC, because we had a strong RFP, because we had a very strong SOW and a strong partner, we're able to lay out what are our work streams and how we're going to do our work. So these are kind of the 7 sisters from discovery, design, build, implement, which is implement in our mind is making it all work together. Once you get into UN, you've got to make sure it's all configured and working together so they play nicely. And then train, test, and deploy. Along the bottom is our test migrations. So we take each of our commodities through a test migration through Heidi. We get it through, we clean it up, and we continue on. So those are kind of the steps to get our data all the way through. and our history. So I'm not going to go back the full number of years. I'm just going to look back 3 years. So these are kind of some milestones that we have across our work streams as we get to the finish line when we actually get our work finished. Our first go live, our first production will be in the spring of next year with our gas data. And I've identified on their OMS, it's a critical point. At the end of 26, we've got to have our sync working so we can sync data to it and eventually go live with our distribution. That's where we are now. So we're on edit tool selection has happened. We're going to be working with them to get our edit tools to start working. So that's kind of where we are, and I'll hand it off.
And I get to wrap us up. Most of this is pretty obvious. It's just what's happening next, and it's things that Dax and Joe have already described. I would like to just share that we have indeed selected an edit tool now. It happened just last week. So we are going to be working with Schneider and implementing ArcGIS 11. So we're looking forward to that. And I just would like to say that we really appreciate UDC's partnership. We've been working with them for 2 years, and we still like them a lot.
UDC.